Okay, in this video, we're going to talk about the rules for the horizontal asymptotes or when there will be an oblique asymptote. So now we're talking about what is the graph doing at its ends when x approaches infinity and x approaches negative infinity. So we're really talking about the end behavior. So we really have three possibilities. The first possibility is the degree on the top is smaller than the degree on the bottom. So a smaller degree over a larger or bigger degree. So for example, we could have x plus 3 divided by x squared minus 2x plus 1. Okay, notice the degree on the top is 1 and the degree on the bottom is 2, right? Anytime we have a smaller degree over a larger degree, this is the one we've already talked about. We have a horizontal asymptote at y equals 0. Okay, y equals 0. Our second possibility is we have the same degree on the top that we have on the bottom. So for this example, we might have x plus 3 times x minus 1 divided by x plus 3 times x plus 10. Okay, so notice that we actually have a quadratic on the top. It's really going to be x squared, and on the bottom we also have a quadratic, x squared. You might be thinking, well, I definitely noticed x plus 3 over x plus 3 could be reduced out, right, or canceled. That's true, and notice that it's still the same degree on the top and the bottom. So this would be degree 1 over degree 1 then, and that's still okay. Okay, you're going to have a horizontal asymptote, and that horizontal asymptote is going to be y equals the ratio of the leading coefficient divided by the leading coefficient. Okay, so in this case, because the leading coefficient would be 1, right, this would be x squared over x squared, we would have y equals 1. Okay, so for this one, it would be y is equal to 1. To look at like one more example like that, if we had 2x cubed minus 1 over 3x cubed plus 2x squared, whatever, right? The other terms are not relevant. We're really looking at that first term with its degrees, the leading term. Our horizontal asymptote would be y is equal to 2/3. Okay, we're looking at the 2 and the 3 there, the leading coefficient divided by the leading coefficient. Okay, our final option, our final possibility is that we have a larger degree function on the top and a smaller degree on the bottom. Okay, so for example, if we had 2x cubed minus 1 on the top, but on the bottom it was just 3x squared plus 2x. Okay, so now the degree on the top is 3 and the degree on the bottom is 2. Clearly a larger degree over a smaller degree. We have what is called an oblique asymptote. There is no, absolutely no, horizontal asymptote. Okay, instead it is oblique. What that means in this case, because it's 1 degree more, so like if you think about dividing 2x cubed by 3x squared, wouldn't you end up with an x as your term. So it will end up as a line, and it will be just a diagonal line. They sometimes call it a slant asymptote. Oblique also just means like at a diagonal or at an angle. You also could end up having some other function as your asymptote. So if the degree on the top was 4 and the degree on the bottom was 2, when you divide those, you would end up with a squared, and so you would end up with a parabola as your ending asymptote. You usually aren't going to have to graph those yourself, so we're going to mostly focus on 1 degree lower on the bottom than the top, okay? So for in this case, let's not go ahead and find that oblique asymptote, but we will do an example in the next video of finding those asymptotes.